Alright, since we had so much trouble with the probability density functions in class on Thursday, I thought I'd make a quick video going through the quiz that my online class has to kind of check in to see if they understand what we're doing. So, one of the first questions here, and you can see I've unfortunately made this video twice already, once with my microphone on the floor, and then once where I accidentally closed the recorder and the recording didn't save. So this is my third time making this. So the answers are already done, but we can still do the questions. This question has a triangle with a certain area of it shaded. We're looking at the probability of x is greater than 300. But the question doesn't actually ask us about that probability. Instead, it just says, is this a valid probability density function? In order for a density function to be valid, it does need an area under the curve of 1. So this is where we're going to use the area of a triangle, which is just 1/2 base times height. So 0.5 times, we need our base. If we're going from 100 to 800, we've moved 700, right? That's the base of this triangle. If we're not sure, we can count it over. 1, 2, 3, 4, 5, 6, 700. So there's my base. And then the height of this triangle is just, looks like the tallest point is at 0.002. So this is just the area of a triangle. I know this is what was breaking everyone. The 1/2 is part of the formula for an area of a triangle. 1/2 base times height. If we do that, it looks like we don't get a probability of an area of 1, so this cannot be a valid function. So we are going to go ahead and say, no, the area under the curve is not 1. So the next one is another triangle, which I think is good, considering that's where we lost our minds. And you can see now this triangle is much taller. It goes all the way up to a 2. Does not matter the height of the triangle, height of the probability density function means nothing. What matters is the areas. So we're still going to be looking at whether the area under the curve is 1 or not. And this is still a triangle, so we're going to do 1/2. The base of this triangle, we're going from 0 to 1, so that's 1. And then our height is 2. So sure enough, 1/2 base times height gives us a probability or an area of 1. So the entire sample space has a probability of 1, which makes this a valid probability density function. So our last one, I think part of the problem with what we handled in class was I added too many bells and whistles at once. I had us finding the height and finding the area instead of just giving us a height and having us find an area. The reason was I was making them on the fly and I couldn't figure out where those heights needed to be as I drew random things. So here's one that would be similar to what you guys will see on your knowledge check in class. So you have a little drawing, which is a composite figure. If you want to think of this as a triangle with a little rectangle and another triangle. It's also just a trapezoid. But this is a probability density function. If we wanted to check, it doesn't ask us to. It asks us to find a probability. But technically, the area of a trapezoid is 1/2. And then you look at the two different bases of your trapezoid. And you basically, that's what the 1/2 is, you're going to average them. So we're going from 0 to 8 on the bottom, and we're going from 4 to 5 on the top. So 8 minus 0 is 8, 5 minus 4 is 1. Those are our two bases, times our height of 2/9. Sure enough, that's an area of 1. You could also have done the two triangles and added them to the rectangle, but we don't even need to know this right now. What we want to know is what's the probability that x is greater than 4. So we're looking at 4 and above. There are 3 different ways to find this. Method 1, we can go ahead and say we want the area of this rectangle from 4 over, right here, there's a little rectangle, skinny, tall rectangle, plus the area of this triangle here. So the area of a rectangle is just length times width. And the area of our triangle is still that 1/2 base times height. So the rectangle here, the length is from 4 to 5, that's only 1 wide, or the length, 1 long. And then the width is at that height of 2/9. So you can see that's just the rectangle portion right here. And then our triangle, we have our 1/2, and then our base, if we're going from 5 to 8, our base is 3, and we're still 2/9 tall. So if you add all that up, you get 5/9. So that's one method. Method 2 is, since if I cut this off at 4 and above, it's still just another trapezoid. We could use that trapezoid area. which is 1/2 the two bases added together times our height. So the first base is 1. Now I've switched it up and calling the top one the first base. And the second base, we're going from 4 to 8, so that is 1, 2, 3, 4. So that's where the 1 and the 4 came from. And then our height is still just this 2/9. So 5/9 a different way. The third method, which is probably the simplest, this is sort of what Rivka said about that one complicated one where I broke my brain. I could just figure out the other side, right? If trapezoids and composite figures are gross, and they are, I can see that 4 and above gives me this gnarly shape that is a little more confusing, but 4 and below, well, that's just a normal-ass triangle. That's awesome. So if we want the probability that x is greater than or equal to 4, or just as greater than 4, that's the complement of x being less than 4, right? So we can just do 1 minus x is less than or equal to 4. So if I want this side, I can look up this side and subtract from 1. So that triangle is just 1/2 base times height, and our base here is 1, 2, 3, 4. So there's my base, the 4. Height is still at that 2/9. This was the problem we ran into with the one I did in class. We ended up like right here. We weren't sure exactly how tall the triangle was, but you'll see all of these come back to the 1 marked spot, and we'll just figure out what that is, which is 4/9, and subtract from 1 to get our 5/9. So this is 3 different ways to get to the same thing, and it's really all about whatever you are comfortable with on that knowledge check. The last question here just says, what's the probability that x is equal to 5? That would literally just be the line here at 5, which has no area. Remember, that's just approximately 0, which is why technically on this cute little document, I didn't need to have an equal sign. If I did or did not, it would have been the same thing. Because for continuous variables, it doesn't truly matter. Though if we're talking about things like our discrete variables with like the binomial, it really does matter. We have to pay close attention to whether or not we include or don't include that 4. So anyways, I hope that clears things up. Yeah, that's it.